Hello everyone, in this video let us solve this question. So we have in bracket minus 9 all raised to the power t is equal to 9, and here we want to solve for the value of t. So t is the unknown what to solve for. To do this, solution, so we have in bracket minus 9 all raised to the power t is equal to 9. So looking at this, we can express minus 9 as minus 1 times 9 all raised to the power t is equal to 9. So from here, you see, if you have I squared is equal to minus 1. So that means that we can replace minus 1 with I squared. So this then becomes, in brackets, I squared times 9 all raised to the power t is equal to 9. So from here, the next thing we're going to do is to introduce logarithm to both sides of the equation. So we have logarithm of I squared times 9 all raised to the power t is equal to 9. And following this rule of logarithm, that if you have logarithm of a raised to the power b, is equals b times logarithm of a. Applying this rule right here, power t comes here, and then this becomes t times logarithm of I squared times 9 all is equal to 9. So from here, the next thing we're going to do is to also apply this rule of logarithm, that if you have logarithm of a times b, this equals logarithm of a plus log b. Applying this rule right here, what we then have is this. We have t into brackets logarithm of I squared plus logarithm of 9 is equal to 9. So from here, to then solve for t, divide both sides by log I squared plus log 9 over log I squared plus log 9. With this, log I squared plus 9, we cancel out this. All we have is t is equal to 9 over log I squared plus log 9. Such that from here, applying this rule of logarithm, that if you have logarithm of a raised to the power b, this equals b times logarithm of a. Applying this rule right here, the value of t is then equal to 9 over, so power 2 comes over here, it becomes 2 times logarithm of I plus log 9. With this, we have gotten the value of t. So this is the value of t using the first method. Now for the second method, the question, which is minus 9 all raised to power t is equal to 9. From here, we can express minus 9 as minus 1 times 9 all raised to power t is equal to 9. Such that applying this rule of indices, that if you have a times b all raised to power c, this equals a raised to power c times b raised to power c. Applying this rule right here, power t will be distributed between minus 1 and 9. So this then becomes, in brackets, minus 1 raised to power t times 9 raised to power t, right, is equal to 9. So at this junction, we are going to apply this function called the Bell's function, that if you have e raised to power I times pi plus 1, this is equal to 0. So therefore, move plus 1 over to this side. This becomes e raised to power I times pi is equal to minus 1. So this means that in place of minus 1 right here, we can introduce e raised to power I times pi, right? So this then becomes, we have the value to equal e raised to power I times pi. Then right here, all raised to power t. So all raised to power t times, we have 9 raised to power t equals to 9. So we have 9 raised to power t is equal to 9. From here, applying this rule of indices, that if you have a raised to power b all raised to power c, this equals a raised to power b times c. Applying this rule right here, power t will multiply I times pi. This becomes e raised to power I pi t times 9 raised to power t is equal to 9. So with this, we are then going to apply natural logarithm to both sides of the equation. So ln in brackets e raised to power I times pi t, then times 9 raised to power t, all is equal to ln 9. So if you have logarithm of in bracket a times b, this equals logarithm of a plus log b. And don't forget that ln is equal to log to base e. So we can apply the rule of logarithm to natural logarithm. So applying this rule right here, what we then have is ln right here, e raised to power I times pi t, then plus we have ln 9 raised to power t. So right here, 9 raised to power t is equal to ln 9. So at this junction, also applying this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. So applying this rule right here and here also, this then becomes I times pi t, then times ln e, plus we have t times ln 9 is equal to ln 9. So at this junction, the value of ln e is equal to 1. So this then becomes I times pi t, then times ln e is 1, so plus t times ln 9. So all of this, right, is then equal to ln 9. So multiplying I times pi t times 1, the value is equal to I times pi t, then plus t times ln 9 is equal to ln 9. From here, we have a common factor, which is t. So factorize out t into bracket. Here becomes I times pi plus this becomes ln 9 is equal to ln 9. At this junction, to then solve for t, divide both sides by I times pi plus ln 9. Okay, divide it also here by I times pi plus ln 9. This we divide this, the value of t is then equal to ln 9 over I times pi plus ln 9. So with this, we have gotten the solution for the value of t. So this is the solution for the second method. While for the first method, the solution is this. So with this, the two solutions of t are the correct solutions for the question. So don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.